Good morning, everybody. Welcome to this class on behavior trees and state machines for the Unreal Fellowship Games 2024. Okay, so course outline. So for the next 2 hours and for the corresponding lab afterwards, we're going to be looking at how to control your AI using two of the systems that are built into Unreal. So first of all, we are going to be doing a quick theory and an overview and comparison at the beginning. Or from this, we would like you to understand why you might choose one of these systems over the other, or choose to code your own from scratch. Then we're going to go through an exercise where we will set up a behavior tree, and we're going to go through an exercise where we're going to set up a similar setup, but within a state machine. So let's talk about behavior trees. So a behavior tree has multiple assets which are attached to it, but there are 5 that I think are worth touching on and understanding. So the first thing is we have the behavior tree itself, which is an asset in its own right. And this can be thought of as the brain. It visually organizes the sequence of tasks and their dependencies. And then we have something that's called the blackboard. Now, a blackboard and a behavior tree go hand in hand. I think it's impossible to create a behavior tree without a blackboard, but a blackboard functions as the memory of the behavior tree. It also functions as a way of communicating, passing data between different tasks. We can have multiple different memories so that we can make it modular and able to swap them in and out. Next up, we have a task, and a task is just an action, but it's rather than having a task which would be a code on a function or something on a specific class or actor. This is a class in its own right. And this allows it again to be very modular. We can reference it multiple times, and we'll be able to reference tasks in multiple different behavior trees. And we have something that's called a decorator. Now, a decorator functions as a filter. This will be placed on tasks or within the behavior tree to control the flow of how the tasks work. Finally, we have something that's called a service, and a service is something that checks things. So what it will do is it will periodically go through and run in order to update the variables, probably stuff within the blackboard. Okay. Now, let's jump into the engine, because I think this is probably the best. It's probably easiest to understand if we are inside the actual engine itself at this point. So hopefully, if you fired up the project, you should have something which looks like this. What it does when you run it. So simulate does nothing. Okay, great. So we have a simple level like this. If I press P, I can see that I have my nav mesh all up and sorted, and I've got a whole load of different AI standing around. Now, I'm going to jump right into the exercise, I think, and I will explain the elements as we go along. So if you're following along, if you could jump to the behavior tree category. Now, what's useful, as we're going to see here, is we have a bunch of the stuff already set up so that we don't need to worry about it. We've already got our pawn, and we've got an interface, the level itself, and the controller. Now, what we also have is a directory called finished project. And this will have all of the different code and the things that we are creating, but finished. So part of the exercise, we're going to go through and create these. However, if you do find that you're stuck at any one point or you've missed the code, say, for example, we're creating the change color, you'll be able to jump in, open this up, and you'll be able to see the code in its finished quantity. So if you do miss it, at any point, all of the code is here, including our behavior tree. So yeah, so everything is in this finished project category, or otherwise you can grab them, you can follow along in the slides. Now, if we could start off by, so I'm in the behavior tree directory and I want to create two assets to start with. I'm going to right-hand click, and under artificial intelligence, you'll see that we have 4 different options here. And the 2 that we want is a behavior tree and a blackboard. So if I come up here and select a behavior tree, I'm going to call this one BT for behavior tree. I'm going to call it NPC. Now, next to that, if I come up, and I'm going to create a blackboard. And for this, I'm going to call it BB underscore NPC. So this will be our behavior tree and our blackboard. Save all. So again, what I've done there under artificial intelligence, I've created a behavior tree and I've created a blackboard, and I've named the behavior tree BB underscore NPC and the behavior tree BT and the blackboard BB. Okay, now I'm going to double click on BT, so the behavior tree, to open it up. I'm going to dock it at the top here. Now, there's only one thing that I want you to do before we start, and that's to check that we have the correct blackboard asset. See, at the moment, we've got BP underscore finished. I want to use the not finished one here. So just BB underscore NPC. And that is going to give us our blackboard asset. Okay, so let's talk about the interface to start with. I think it's probably a good starting point. Now you can see that we have what is very similar to a blackboard or a lot of the other interfaces that we've been working with in the center here. If I right-hand click, I get a little hand, which allows me to move it around. If I use the scroll wheel in the center of a mouse, I can zoom in and I can zoom out. And if I right-hand click, I can add nodes in. So this is a common interface which we've been working with quite a bit up to this point. Now, there are a number of different functions. So there are a couple of, let's look at the other places before we start creating stuff. Now we've got a couple of options here. We can create a new blackboard. We can also do things like create new tasks and new decorators and new services. So we talked about them before. Tasks do something. Decorators function as a filter to control the flow, and services periodically check values, update values. Now, on the right-hand side, we've got a details panel. Again, details panel, if I bring in, so if I created a sequence, you'll see that this is contextual. And we have a blackboard element. Now, blackboard is going to be one of the things that we need to get our head around, because these function like variables. And we've been working with variables for quite a long time now, so it's quite common to understand variables. However, the way you work with them and the way you interact with them is quite different, because we work with blackboard keys rather than actual blackboard values themselves. Now, if you can see that we have a tab across the top here, if I hit Blackboard, this is going to jump us into the Blackboard, and we will set this up as we're going. We'll set this up as we go on, but just understand that these are the tabs. Now, we have in the center here the root. And this is called a behavior tree. And it would be better if it was kind of called roots, sort of the behavior root system or something, because rather than going up from a behavior tree, we go down. And we go down and we go to the furthest left branch, and then we move forward into the other ones. But let's talk about the standard nodes that will build our tree. So if I drag off of the roots and drop this down, you can see that I get three options. We get a selector, a sequence, and a simple parallel. Now, I'm not going to spend much time on the simple parallel, but what the simple parallel in short would allow you to do is it allows you to run two tasks at one time. So you'll be able to have one section of it'll allow conditionally for you to run a behavior tree beneath something whilst you are also carrying on with another state. I'm not going to cover simple parallels in this exercise. If you want to ask about them in the lab, or we can go into playing with them. But it allows the running of two children, one which must be a single task, and the other which can be a complete subtree. Now, what we really need to understand is the selectors and the sequences. So you really, 90% of the time, if you are in any behavior, 90% of the time, you want to start your behavior tree with a selector. Now, what a selector is, if I was to build out this out of lots of selectors, let's start off with this. So the first thing is we've got no tasks here, so it's a bit silly because there's nothing it's actually doing. But we can talk about how this would navigate through the course. Now, when you bring into your behavior tree what will happen is this will always it will always start at root. Then it will move down to the selector. And with the selector, what a selector will do is it will select one below it. Now, actually, sorry, something that's really important to understand is any task or any task that we place in. Actually, I'm gonna replace these with tasks. So I will I'm gonna go make noise. So let's go. And so a whole load of make noises. Now, any of these tasks, when you write a task, the task will continue until you provide a fail or succeed. So you finish a task at the point it either fails or succeeds, and then the behavior tree is going to decide what to do next. So what a selector will do is it will come down here. So it follows the left-hand side. So it goes, okay, first try this one. So this will be the first node it goes to. And you can see in the top corner here, we've got 0, then we've got 1, 2, and 3. So this is denoting the order that something is going to be tried. And one of the things that's important to understand is if I move this to the left, you can see this becomes 2 and that becomes 3. So the location of the nodes is actually important in a behavior tree. And that's not the same anywhere else in blueprints, materials, and so on. Where you place your nodes doesn't matter. The only thing that matters is the order that they are, the order which they are, how they're connected up. But here, the order does matter. Now, what a selector is going to do is it's going to come down and it's going to attempt to do the first task. Now, if this task returns a success, then it will go back to the root and it will go down the selector again, and it will attempt this task again. If this is successful, it will go back to the root and it will continue doing that path forever. However, if it comes down this and this fails, it will do the second task, or it'll attempt to do the second task. Now, if that fails, it'll come back up to the selector, have this whole thing as a failure, and then come down this second pass here and try this here. So what a selector is going to do is it's going to try and action any of the points below it. And as soon as it receives a success, it will go back to the root. If it goes to a failure, it will attempt the next element under the selector. And I think the way I usually try and describe this is if I typed in, I don't know, work. I know. So if I had a selector for go to work, okay, and under the selector, I'm going to choose. So drive to work, catch the bus, walk. Now, with the selector, if you come to a task that says go to work, the first thing it will try to do is drive to work. And if it's successful, then whole go to work is a success. However, if it goes down and it wants to drive to work and it finds the car is broken, or you don't have a car, or something like that, then it's going to try and catch the bus. So, and if that's a success, then going to the work is a success. Now, however, if the buses aren't running, then it's going to try and walk. And if you can't walk because one of your legs are broken, then you have failed the whole task of go to work. Once you've failed all of these, you have not succeeded going to work. And so it's important to see that whatever it tries them starting from the left and it moving through these, and it will keep trying until it's attempting to do a successful go to work. Now, let's talk about sequences and how they vary. So the other option that we have when we drag off of something is a sequence. Now, what a sequence will do is it will, so I'm just going to call this earn money. In the world of remote working, this is less, not as good an example anymore. But switch on computer. Okay, so and now what a sequence will do is for a sequence, for earn money to succeed, you need to complete all of these with a success. All of these need to be returned with a success. So to earn money, the first thing you have to do is go to work. Second thing you need to do is switch on the computer. Third thing you need to do is work. And the fourth thing you need to do is go home. Go home is a slightly optional one. You could still earn money without going home, theoretically. But the point is that if any of these fail, so that once this has succeeded, once going to work has succeeded, you're going to go back up to the root. You're not going to go back up to the root again. You're not going to go back and go to work again. What you're going to do is you're going to go back to the earn money and you're going to get to the second action. And then if that succeeds, you're going to go to the third action. If that succeeds, you're going to go to the fourth action. If that succeeds, the whole of the earned money succeeds, and we go back to the root. We come back to the earn money. Now, if any of these fail, if switch on the computer fails, the whole earn money task fails, and you go back to the root, and it tries to go to work again, and it goes through them. So I know it's not the world's greatest example, but selectors and sequences are just one of the things you need to understand how you navigate through this. So a sequence will go each of the tasks. When successful, it will go on to the next task. A selector, when it's successful, it will mark the whole task as completed, and it will go back up to either the start. So when go to work is thinking, it goes back to the sequence. Okay, so those are the differences. How are we doing? Is there a general confusion over that, or it's only theoretical at this point? So it'll make a lot more sense as we jump in and we actually start doing stuff. Does it look good in chat and stuff?
Yeah, looking good, I think. No one's typing.
Okay, right. In that case, let's move on to the next section. So I'm going to delete everything but the selector at this point. We will start anew. Now there is one thing that I need to do to get this whole thing to run, and I need to do it within the pawn. So I'm going to jump back into the level, and I'm going to find our NPC behavioral tree character. And on event begin play, I want to drag off and type in run behavior tree. Might have to do it from the AI controller. Get AI controller, run behavior tree. And I need a reference to self. Now, once I've done that, I need to do a drop down and select the BT NPC that we have here. So that's the behavior tree we created. And this is just so that it knows that it's got to run that behavior tree in order to get going. So again, that's on the begin play of the NPC character. Okay, so I'm going to hit compile and jump back to the NPC behavior tree. And let's set up the blackboard sponge. So in the top right-hand corner, if you can come across to the blackboard, you should get a screen that looks a bit like this. Now in this, we want to add in 2 new keys. So under the first one, I'm going to push new key, and I want this key to be of the type vector. And I'm going to call this location. And the next key I want to be of the type object. And I'm going to call this player. Now, I'm going to, with the player, we'll see on the right-hand side that we are of type object. Now, I would actually like to reduce the base class because I want to be able to get it to follow this object. And so in order to do that, an object class isn't good enough because the base of an object class is doesn't have a transform. So I want to change this to be an actor. So you can see So this is an object reference, but the base class is actor at this point. So we have two settings. We have the location, we have the player, but the player is an object with a base class of actor. I'm going to save that, and I'm going to then go back to our behavior tree. Okay, so we have our selector. And the next thing that I want is I'm going to create a sequence. So if you drag off and create a sequence, and if you could rename the sequence to wander around. It's useful to name these so that we can tell what's going on at any one point. And this is what we're going to have as the NPC's default activity. Now we need some tasks. So what I'm going to do is I am going to, we need to create a new task. So you can see up here, we have new task as a option. If you do the drop down, it's going to ask us what base class we want to pick from. Now, if you can select the last one down, which is BT Task Blueprint Base, this is the base class for the task nodes. And so if I select that, it'll ask, I want to know where. And I'm going to add this to the behavior tree, the category. And I'm going to name this BT underscore find random location. And I'm going to hit save. So this is our first task, find random location. Now, as you can see with this task, there's nothing in here already. So we need to come up and we need to use the overrides again. So if you look under functions, we have a number of functions that we can override at this point. And we've got options of receive abort. So abort would be when a task is finished aborted, which is caused it to abort. Execute is when it is started, and receive tick is when receive tick is whilst the event runs, it will have a tick which runs with an event. So this is the tick for a specific event. You'll notice that there is an AI next to option for each of them. And I'll just demonstrate what the difference is. So you can see here, it's the options that you get out of it. So with the receive, you only get the owning actor. With event execute AI, it will give you the controlled pawn and the owner controller. So in this case, I think it doesn't really matter too much. I'm just going to go with the standard event received. So in order to get that again, on the functions, we're going override, event, receive, execute. And that will give us this pin here. Now, all this event does is it finds a random location. Now, so we want this to be an event which is reusable all over the engine. So we're going to change some of the settings in it. Now, the main thing that I'm going to use is the get random reachable point in radius. So that's a node that looks like this. It's pure, but what it does is you give it an origin, you tell the radius from that, and then it will pump out a random location within that, which is presently reachable. so that your AI is going to be, according to the nav mesh, your AI should be able to walk to that location. So yeah, get randomable reachable. Now, the first thing we need is a origin, and we can do that by getting the actor location. Plug that in, because that gives us the location. Now, the radius, I would like this to be editable as we're going through. So I'm going to right-hand click, I'm going to select promote to variable. And then we have radius. Now, I'm going to make this instance editable. Yeah, make this instance editable because this should allow us to edit it on the setup of the setup of the node. Now, the next thing that I want to do is set Blackboard. So next thing is I'm going to need to pass this value between tasks because we want to find a location and then we want to use that location in another task. So in order to do that, I need to use the Blackboard. And we can't use a standard variable. We need to use a Blackboard key in order to do that. So what I'm going to do is I am going to set Blackboard value as vector. You can see the final one down here. We have a set Blackboard value as vector. So this means I want to save a vector into this Blackboard value. And that's going to give me a node which looks like this. Now I can plug the value into the value spot, connect this up, but I'm going to need a key. So if I right-hand click, I can promote that to a variable. And I am going to rename that key to location. Now, this is the correct code. However, if I ran this task at this point, we would never leave this task. And that's because we are not providing it with a finish execute. And this is one of the things that I kept missing when I was doing other stuff. And that's you have to tell it that the task is finished. And in this instance, I'm just going to connect the returned value to the success. So if we have successfully found a reachable point in the radius, then we are going to finish successfully. If we failed, we'll finish as a fail and it will abort the entire sequence. Okay, so hopefully you guys have something that looks like that. Oh, the other thing is the location needs to be instance editable because we're going to be, so both variables need to be instance editable. Correct. Congratulations. That's your first task. Everything looks good to me. So compile and save. And let's go back to our behavior tree. And if we drag off, we can now search for, what do we call it? Find. So we've got find random location. If you had trouble with it, there's already a finished version in there, but find random location. Now, what's interesting is if we look at the top, you can see that we have some defaults here. The first default we've got is radius. And we're going to want to increase that radius. So let's make that 1,000 because otherwise it's not going to do anything at all. And we've also got location. Now this is where the thing becomes important because if you can see location, we need to save the location to a Blackboard key. By default, it's going to save it to self actor, which is wrong. For a start, that's an actor, and we're trying to save a vector in. So it's not incredibly intuitive this. But if I was to do a drop down, I can choose location and save. And so the first task is done. Find random location. We're doing it in 1,000 distance, and we're saving the value out to the location. Now, in order to finish this up, all we need to do is to tell it to move to. So we go move to. And for the input, we don't want it to move to itself. We want it to move to the location. And the final task, we just want it to wait. And we'll make it wait for 1 second, I think. So this should be our first task, first behavior tree. It's very straightforward. It's just going to wander around. It will find a random location, move to it, and wait for 1 second. Now I'm going to test this out. And we should see if this is working. So I'll save it, and I'll just push simulate, and hey presto, all of our characters are randomly walking around. So they're finding a random location quite close to them. They are walking to it, and they are stopping there and waiting for a couple of seconds before carrying on. Okay. Now, I want to finish off behavior trees before we take a break, because then we'll go on to state machines. But is anyone having any major problems in chat? The other thing is quite interesting is you can watch the behavior tree as it's running. So that's really quite nice.
Yeah, I think no one is moving for anybody. There's like 5 people that said no one's moving for them.
So a lot of people are saying no one's moving.
Yeah.
Okay, right. Well, so in that case,
Edward, I think there's a hidden kind of compiler, because if you don't put the self reference into get AI controller, you don't get a compiler. But if you go a runtime, it doesn't compile.
Okay, so
you got it right, but people probably.
So the first thing I would check, everybody, is that you have that running on the NPC behavior tree. So the AI, I think this is new, because if you look at the notes, if you look at the notes, it just says self in there. So maybe it'll run like that. Let me just test that. No errors. Yeah,
No, that's correct. But if you remove the self, the blueprint compiles here.
Yeah.
But then it fails at runtime.
Okay, so that is the first element that we need. Second, I'm going to go through the different elements. You need to make sure it's BT underscore. So make sure you have that on begin play. Now, the next thing that I'll look at is the behavior tree. So the behavior tree, what we want to do is concentrate on the values that are going through here. So the first thing is the radius is default to 0, but you'll want to set it to something like 1,000, or any number over 100 should do. So make sure your radius is there. Now, make sure you're using the location. So that you are saving the variable to location, because if you break this chain of concept, they won't move. Next thing, on the move to, make sure the blackboard key says location, and wait needs nothing. So your stuff should look like this. I'll go back over the other element in a minute.
I think that fixed it for a lot of people.
Okay. Yeah, it's you think I'm good to continue? Because
There's a few people typing. Let's just see if there's. Okay, people saying it's working.
the other thing is the finish execute. If you forget the finish execute here, it will get stuck. I'll demonstrate it. If I do the finish execute and I remove that and run, you can see that it just goes to the fine random. It'll never leave there. So we'll just carry on indefinitely with that. So doing Control P on here is quite useful because you can see what the behavior tree is doing. And once you can tell that, you can often figure out where it's failing.
And there's one like high level question of like, why would you not just do this inside of the AI blueprint and just do an AI move to? Like, why would you do a behavior tree? Is it more optimized?
It's not necessarily more optimized. Firstly, it's modular. You can have lots of different behavior trees for different people. Secondly, it's modular. You can divide the code out into different sections. Plus, as things get more complicated, it gets like the simple AI thing that I was trying to show you before. I basically wrote something all into a component. So your other choice is to code something directly. But there are certain things that start to get really hard after a certain point. You have to write a theoretical state machine where you are waiting for tasks to finish and you know when to come out of a task and what state you should be in transitioning between them. Where this is as things get more complicated, this is considerably easier to manage. But if you have a very simple one, you can just write your own code for it. And you'll see as AI gets more complicated and you start using things like environmental queries and stuff like that, it really is it's easier to visualize and see where anything is at any one point. Because otherwise, I'll show you my simple AI and show you how complicated it is in order to create the same functionality in a form, just in code. I'll do that in the sort of lab. But this is very modular and it's very scalable. And you can swap out behavior trees quickly. So different monsters can have different settings. Yeah. Okay, so let's carry on from this point because we've still got a lot more to do. Right, so hopefully you have them running about. Let's add in, so we set up the blackboard. Okay, let's create a new task. So if you come back into the behavior tree and select the BT task blueprint base again, let's call this BT underscore change color. I'm creating a task called BT change color. Okay, and again, I need a override. This is going to be quite a simple one. So I am going to do receive execute for this one. Before this, I'm going to use an interface. So all I want to do is drag out from the actor, and I'm going to type in change color. And you can see there's an option for a change color message. And so this is because I have an interface on the AI, which has code which is connected to, and we can look at that here. So there is the change color, which is just a function to change the color of the node. Now I need to do two things. First thing is I need to promote this to a variable, and I'm going to make that instance editable so that we can decide what color we want this code to be. I'm going to drag off and type finish execute. And I am going to presume this is a success. So that is the entire code that we need for the change color. All we are is really sending an interface message saying, I want you to change to this color. And why an interface is nice, again, is because if we're keeping with modular, let's say you've got 50 different creatures and they have different ways of changing color or something, you might have different functionality to do this. So that gives us the change color. Compile. Now I'm going to come in, I'm going to create one more, and that's I'm going back to the behavior tree. I'm going to create a new task from the blueprint base again. And this is going to be change speed. Okay, so again, we're creating a new task and we're calling it change speed. And again, I'm going to look at the override for receive execute. And this is almost identical. Dragging off of the actor, I'm going to type in change speed. Again, we already have an interface set up. I'm going to promote to a variable. Which recall it speed and make it instance editable. And I'm going to do a finish execute. And presume it is successful. So these are our second two tasks at this point. We're just changing the color and we're just changing the speed. Okay. So I'll finish execute and I'll finish execute here. Now let's jump back to what's next. Let's update our behavior tree. So when we're going to find a random location, but before we do that, I want to change the speed. I'm going to change the speed to 200 because if he's just wandering about, he doesn't need to run everywhere. So he just walk everywhere. And I'm going to change the color. Now, in change color, I'm going to change the color to, I'm going to go with yellow. So I'm going to change the color to yellow. So now our wander around looks like this. We change the speed to 200, and then we change the color to yellow. Find a random location, move to that random location, and wait for 1 second. One second. Okay, so let's test this out. Looks like it's working. All of the characters are now just slowly walking around. And I'm going to finish that. Okay, so let's add in a different state. And to do that, we're going to use a service. So we're going to allow the functionality that this character can chase the player. And so what we're going to do is under the selector, well, we're going to come up and we're going to create a new service. So at the top, you're going to come down and select is player close. So we're going to use the BT service blueprint base. And I'm going to call this BTS is player close. Now, let's build this one first, and then we'll put it into place. So for this one, I'm going to override search start, but I'm going to use the search start AI. And that's because we need, no, actually, I'm just going to use search start. Get control pawn. Get control pawn. Oh, okay. Wait 1 second. I'm just looking at the code. Oh yeah, so that is just getting the AI controller. No, okay, so I'm going to use AI start search, and that will provide us with the controlled pawn. So first thing I'm going to do here is I'm going to go get player pawn. So this is going to provide me with the player. Now, this is not the way you'd really want to do it. You'd really want to have some kind of site function so that it could look for characters and stuff like that. But this is just a simplified method so that we can test this out. Or you might want to, we're not doing environmental, the reception component or environmental query in this session. So we won't get into those. So we're gonna fake this. So what we're gonna do is we're gonna get the player pawn, and the first thing we can do is check, is it valid? So we'll get the player pawn, and if it is valid, we are then going to get the controlled pawn, get the actor location, and we're going to get actor location again. So we got the actor location of the player pawn and the controlled pawn. And then we're going to look at the distance between the two of them. And it comes out as a vector. So we have two vectors. So that is going to give us a float of how far away these 2 points are. Now we're going to say, is this less than, and we got in here 150. And then I will do a branch. So what this is doing is we're getting the control pawn and the player pawn. We're checking the player pawn is valid, because if we come in simulate mode, it will just error consistently. If it is valid, we are looking at the actor load. We're taking the two locations. We're using a distance node to just figure out how far apart they are. And if the distance is less than 150 centimeters, we will go down true, false, we'll go down false. Now for this, at the end, we want to set a blackboard value as object. I'm going to duplicate the get player pawn, plug that in as the value. I'm going to right hand click and promote the key, change the name to player, make it instance editable. So if we are close to the player, we are going to if we're close to the player, we're going to save this as a actor value. I'm going to compile and save. Slightly different to the stuff that is in the if you're following the notes, this is slightly different because I get the NPC character on search start. Oh, wait a second, it's not. Yeah, I've actually got this wrong. It shouldn't be search start. It should be receive tick. So receive tick AI. That is wrong. Sorry. So I was wrong. It should be receive tick. Now, in a service is a place where you really should be using tick because it's very rare that a service would have a high level of tick anyway. It wouldn't run on each frame unless you really wanted it to. And it would, and otherwise it's pretty useless really because you need to be updating stuff. I'm going to compile and now save. And I'm going to jump back to, hopefully you guys have got that. And jump back to the behavior tree. No, the behavior tree like this. And I want to run this service on the selector. So when I get the selector, I am going to come in and you can see I've got the option for add service. And I'm going to use BTS is player close. And did I is player close? I'll need to make sure this is instance editable, otherwise we can't save out the variable to the. Now, I don't want to save the thing into self actor. I want to save it into player. Okay, so that is player close, and we're saving out into player. Now, what's interesting is you can see here the tick is quite interesting in this because the interval, so it will run every 0.5 of a second tick standardly, and it has a random deviation of 0.1, which is quite useful because the random deviation is really useful because say you have, with AI, you might have 1,000 of them. And if all of them ran on exactly the same tick at every 0.5 of a second, you'd find the game might slow down every 0.5 of a second while it goes away and does the service. Where what a random deviation would mean is that it spreads it out. So all of the different AIs will be running this service check at different times. So it smooths it over rather than giving you a spike, meaning the game can run smoothly. So yeah, we need to use tick on a service. Right, so we've done the code. Next up, what I want to add is a decorator. Because we talked about decorators before, and what they do is they control the flow. So if I come in here and I add a decorator, what we want to do is we only want a decorator, a blackboard. And this means what we're going to do is we're going to use the blackboard to determine if we go down this route, a blackboard value. So on wander about, I'm right-hand clicking and I'm selecting add decorator and I'm coming to the blackboard. Now, with the blackboard itself, what I'm concerned about is the player. So what I need to do is this is going to block it if the player is not set. So it will not go down this path if the player is not set. I can change the name on it as well if that helps and go. That sort of makes it easier to read. Player not set, wander around. We can change the and change the names of things. So we've got that now set. So the player is not set that, and that should detect the player if it's close. Now, what I want to do is I want to do the other path because we've got one path now, but let's create a chase, a follow branch. So from this, I'm going to drag off the right-hand side and I'm going to type follow. I'm going to add in another sequence. And this sequence I'm going to call follow player. Space in there. Now, I know that the player is going to be set because otherwise it would be doing this task on the other side. So I'm going to make a new task at this point. And what I might be able to, let's create it space by space. So the first thing I'm going to do is I'm going to change color. So I'm going to change color and I'm going to change to red this time. So, okay, I'm going to change the color to red. Now this gives us enough to test it. So let's do a test at this point. Well, I'll leave that visible so everyone's got a chance. How's it looking in chat? We haven't got long to go, and then we'll take a break and go on to state machines.
I think we're all right overall.
Okay. In that case, I'm going to test. And so I'm going to use select viewport now. Now, what's interesting is you can come up to this guy here. If I follow him around, you can see he turns red. And that's great. So it's working. But what's not good about this is he's not doing it immediately. So if I run up to one, they have to wait until they finish their action before they change color. And that's because if we look at our behavior tree, what happens is it's going to do this whole thing and it's going to wait, and then it's going to come back to the decorator again. So as soon as it's got past this decorator, it's going to do all these things and then come back up to it. Now that's not ideal. Say we wanted it to spot immediately and we wanted it to cancel out the wandering around to start following the player as soon as it detects them. Well, we can do that by using something that's called a abort. So on the decorator, you will see at the top we have an option for observer abort. And we have two options on it's observer abort. And if you do the drop down, we have a number of different options. And we're going to go with self. Okay. And what that means is as soon as it changes this value, it's going to abort this path below. So if I now try, you'll see as soon as I'm detected, they stand still and turn red. It's still not instantaneous, and that's because I'm only running the service every 0.5 of a second, but it's pretty good. Right, now, hopefully that's working for everybody. I'm just going to do the last couple of nodes, and we can then do this as finished. So the next thing I'm going to do is I'm going to change the speed. So they were at 200 before. I'm going to change their speed to 500 because they're in pursuit. And the final thing I'm going to do is I'm going to go move to, but this time, the input value for the move to, I'm going to change to the player. So we know that the player is set. So we change the speed, we change the color, and we move to the player. Again, we need to make sure we change the color. We set the input variable of the color, and the speed, we change the speed of the player. Now I'm going to do save. I'll jump back in. Now, They're going to run after me as I get close to them. You can see we have a very basic behavior tree. And this is what your behavior tree should hopefully look like at this point. Well, I'll focus on this slide so you can actually read it. Okay, so that puts us, we're 15 minutes past. That's a pity. But I'll give you guys a 5-minute break. So we'll start at 20 past. If you've got this working, I'll move on at about 20 past. Otherwise, if anyone's specifically stuck, I can show sections. Is anyone specifically stuck, or do people have it working?
Yeah, I think a few people, the AI just ignoring the player.
So make sure you save the output of this to the player. I think that's one of the big points that we fall off. Otherwise, at this point, to be honest, if you want to check if it's working or not, you can always add the finished version in. But this is the code for the is the character close. Usually I'd do a much more complicated. I might use line tracers, or I might use the perception component or something else in order to get this down. But this is a nice basic function so that we can play it. If you're having too much trouble at this point, don't worry, because we're going to be moving on to the next exercise, so we don't need to worry about anything that's in them. So next up, we're going to be going to the state tree directory. And in this directory, we've got another level that's called state tree level. And if you'd like to just load that up, you can save what you've already been working on. You should get another level which looks very, very similar. The only difference is our little AIs have a kind of taser-esque club attached to them. There's an amazing bit of modeling I've done there. Beautiful, beautiful. But it'll help us do a bit of a fight. Okay, so let's look at the notes. State trees. State trees are function slightly differently to behavior trees. So now you've just got your head around the behavior trees. We're going to be playing with state trees to see how they function differently. Now, a lot of the elements are equivalents. So this sort of shows how they are the equivalent. A behavior tree is the equivalent of the state machine. Is it state tree? I think it's state machines. State machine. Service is an evaluator. So where a service is something that checks for values, the evaluator in this circumstance does a similar serves a similar role. Now, the blackboard, instead of the blackboard, what we're going to be using is something that's called binded variables. And this took me a while to get my head around. So we are going to connect variables to the state machine. Where we used decorators in the previous one in order to control the flow, in this one, we're going to use something that's called entry conditions and transitions. So if you remember that we created a state machine for the animation blueprint, The state machines in this function in a relatively similar way, that we can jump to any state from any other state. We just need to define the movement between the states. Why use state trees? Well, a state tree is the main reason we use a state tree is it has a more controllable transitions. As your AI gets more complicated, you'll find that behavior trees, the traveling between trying to have numerous tasks going on at the same time, it gets a lot more hard to manage. I mean, in most cases, you should be all right, but as things get more complicated, you want something a bit more complicated, a bit more able to manage it. Secondly, it's not tied to the AI controller. You can have a state machine which could function, for example, with a chest, and you could have a state of open, closed, locked, and you could have it do different things depending on the state that the chest was in. It's used massively in Fortnite because walls and stuff like that, they all have different states they can be in. Finally, is performant. A state tree is slightly more efficient as it involves fewer checks and logic operations. It uses fewer checks and logic, where a behavior tree can become quite resource intensive. Okay, so if you want to use the state tree, you need a plugin. Behavior trees function standardly out of the box. I think there is a plugin with them, but it's on by default in 90% of the cases. For the state tree, it is not. We need to turn on the state tree, and the gameplay state tree it's a new version which gives you extra functionality to specifically work with AI. Okay, so
Just a quick question, Ed, if you've got a second.
yeah,
It's just a question of like people understand the advantages of state tree, but why would the behavior tree be better in any cases?
well, if you're doing, I mean, the behavior state trees are what we're looking to move things towards in general. It becomes, and so that's why I'm saying in future courses we'll probably phase out the behavior tree. However, it's a bit of a legacy thing, and if you prefer the view, so it's a part of an interface if you prefer it. Unless you guys can think of any, I don't think there's any specific benefits apart from readability. Now we're going to jump into the state trees, and it looks a lot more like code. The code as you're going through it looks a lot more complicated, and it is generally more complicated because and one of the main reasons it's more complicated is because when we look at a behavior tree, it's rare that you would have multiple tasks running at the same time. However, with a state tree, every state can have numerous tasks involved in it. And so when you're looking at a behavior tree, it is a real, like, you go through these paths at this point. Now, with the state machine, you enter different tasks as we'll go into it, but those tasks might have numerous tasks underneath them, which are doing different things, and it just looks more complicated. From a performance, from a flexibility point of view, a state machine is superior. From an ease of use, I think it's more complicated. So that's well, I'll open that up. Emmanuel, James, do you guys have any other sort of thoughts of why a behavior tree is superior?
No, for me it's just visually behavior trees are easier to understand, as you said.
Yeah, it is.
Yeah, I agree.
Yeah, I mean, writing your own code, another option is writing your own code, and that's simpler at the start, but soon becomes an incredible mess. And so behavior trees, if you want simple, like what we've done to this point, you guys have probably all like understand it and could probably duplicate it and work with it up to this point. What we're looking at in state machines is going to be harder if you're not from a coding background where it sort of makes sense to you guys. Um, but I'll show it to you, and you can come up with your own choices. So, let's make a state machine. We have our state tree. Oh God, look at that. Okay, so we have our NPC state tree character who's running around here. And the first thing we need to do is create a new state machine. So if we come up and under artificial intelligence, you can see we have an option for state tree. We're going to create that. And we're going to go with the standard component. We're not going to touch AI. We could touch AI at the moment, but this course was written without it, so I don't want to deviate too far from it. So we're going to go from the state tree component, and we're going to call this stc underscore npc. Again, we have all of the files finished in here. In case you guys are stuck, you can always come in and look at that. Now, let's start off by setting up the state tree component. So I'm gonna close down all of these to start with, otherwise I'm going to get very confused. I'm going to open up the NPC state tree, plug him in here, and you can see that we already have one. So I will delete that to start with just to show how you do it. If you want your NPC to run using a state tree, what you do under components is add, type in state tree, and we're just going to use a standard state tree. It's already there, but that creates a state tree. Now, the next thing that we need to do is set the class. So on the drop down, we want to use the one that we've just created. So it's stc underscore npc. I'm going to go compile and save. So that's all you need to do. You don't need to tell it to run because it will start logic automatically unless you untick this box. So by default, this will run out of the box. Okay, so now I'm going to compile, and I am going to jump back into the NPC state machine. So this is what we will start off with. Now, in the top left-hand side, we have something that says context. Now, context is very useful because this is something that we're going to be able to access from different tasks. So we can use the context keyword in order to access that class. Now, by default, this will be set to actor, but we want to set it to the NPC state tree. Well, this isn't great, but you should set it to as a higher class as you can, because that way you're going to be able to use it with different classes. So if you have a base NPC or enemy class or AI class, it's better to use that. But in this case, we're just going to use the state tree. So we're now going to see that the context actor is the NPC state tree class. Now, you can see that this has a little context thing next to it, and this has got a blue pin. And that's useful because this is now a variable which we can use within a task. Okay, now let's create. So we'll create a task. So again, I'm going to compile. Now, we don't have the nice little option drop down to create a task here. So we're going to need to do this from inside the blueprint class. So I'm going back here, I'm right-hand clicking, and I'm selecting blueprint class. And under all classes, I'm going to search for BT I'm just going to search for task. And you'll see that we have a BT task and we're looking for blueprint base there. Now I've pre-written, I think, all of the other tasks, so we don't have to worry about writing too many tasks. I just want you to go through the experience of writing one. Okay. So we have the BP blueprint base. And I'm going to select this. And I'm going to call this std underscore move to location. Okay, so we have a move to location, and I'm going to double click to open this up. Now, one of the things that I'm going to do with this is I'm going to add a custom description or a node. I think it's a node name. I always get confused, but I'm going to try node name, move to location. So I think when we access this and place it in a task, rather than it being called STTT move to location, I believe it will show up as move to location. I will double check that though. Now,
Oh, Ed, I think you've created a behavior tree task, by the way. If you look at the parent class.
to task blueprint base. Sure.
I think it should be state tree task blueprint base, right?
Yeah, you're right. Wait a second. Maybe. We'll just we've got attack. Yes, you're absolutely right. Okay. Thank you. That would have completely thrown me. Didn't. So I'm just going to change. I'm going to delete this probably. Class settings. Now I'm going to change the parent class. Hopefully I can just swap this over. State. So try and task. Yeah, so I'm going to change the parent class to state tree task blueprint base. Continue reparent. Class defaults. Class settings. Display name. I'll change this to move to location. Thank you for that. That would really have thrown me. That would have been 10 minutes. So just to reiterate what I did there, under the class settings, I've changed the parent class to state tree task blueprint base because I accidentally used the behavior tree. It'll ask you if you want to reparent and then just say yes, and it should swap everything over. Okay. So I'm going to create, again, we're not going to create many tasks because I just want to demonstrate how this works. But I'm going to create a variable. And for this variable, it is going to be I'm going to call this NPC. And actually, if I just call it context, will that transfer the oh, I'm not going to deviate. Okay, I'm going to call this NPC, and I'm going to change the variable type to a NPC state tree object reference. And the next thing that I'm going to do is I'm going to change the category to input. And this is incredibly important because the when you're working with tasks, if you have an input or if you place anything into the category of input and output, what it's going to do is it's going to require those, and it's going to be you're going to be able to bind those variables to other places in order to get the task to work. Now, there's also a category. I think there's a context category as well, but I only found out about that after I wrote this course. So, so in this case, we're using input because we want access to the player, and then just by placing it in this category is going to allow us to fill this value. And then we need to do the same as well for location. So I'm going to create a new one that's called location. And I'm going to change this to a vector. And again, I want this to be in the input category. So in that case, I've just dragged it up to input. So whenever I run this task, it requires a character actor and the location to send them to. So next up, I want to add the code for this. And I'm going to use I'm going to, in this case, do an override again, so we can see what functions are already here. And we want to use the enter state. We've got the enter state, the leave the states. This is code that will run when you leave the state. It's code that will run when it's completed. And we've got a tick, which will run whilst the state is running. So I am going to choose the enter state. And I am going to drag off and do a move to location or actor. And I'm going to drag off of the NPC. I'm going to get the NPC. And then from the NPC, I'm going to get the AI controller. I'm going to plug that into the controller. I'm going to plug the location into the goal location. And now at the end here, if you remember like the last one, we had to do a finish execute in order for it to move on to the next state. Now the same thing works with state trees. However, you might not want to do it with everything because you can have 5 tasks run under a state, and only one of them will be the one which will determine when you transition away from that state. Now, in this case, this will be the one that is transitioning away. So we're telling you to move to a certain location. So we don't want to leave this state until you have actually moved to that location. So I'm going to drag off on request failed, type in finish. And on move finish, I'm going to do finish task as well. But on failed, I'm going to select this as failed. And on finished, I'm going to select this as succeeded. So I'll double check. I don't think we got to do much more coding past this. Yeah, I don't think that is. Oh, there's one more bit of coding. No, we're just looking at something. So this is pretty much the last piece of coding I'm going to be asking you guys to do. Okay, so we'll save and compile. And jump back into our state, our state. So let's create the states. So the first thing is we always start at root. And I'm going to want to add in a state. And the first state I'm going to add in is called idle. I'm going to add in another state under another state that's under idle. I'm going to call this wander about. So we start off in root. You can see that root automatically goes down to idle. Idle automatically goes down to wander about. And we can also see that there is a transition at the end of this that is called root. So after walk wander about is finished, it will go back to root and it will repeat this activity. Now, at this point, we have not actually given it anything to do. It's just moving between states. So let's give it something to do. Let's create the idle, let's create the wander about state. So we don't need an entry. So you can see here on the side with this selected, this is the state. Now we need to ask enter tasks. We don't have an entry condition, but we do have tasks. So the first thing we're going to do is we're going to add in a change color. And we're going to add another one in there, which is change speed. So you can see this is very similar to what we were doing last time. And then we're going to have a find random location. And then we are going to do a move to location. So enter those 4 tasks into the wander about. Now, what we need to do is we need to sort out how we are passing variables between these. So if you open all 4 of these up, you're going to see that we've got a number of different options. And these are all the input pins that we have placed in. So the first thing is we have an actor. If I compile, it's going to complain that it doesn't have the input pins. So let's work with change color to start with. So the first thing we need is the NPC. Now we can get this from the context actor. That's the context there. So for each one of these NPCs, I want to change this to the context actor. So that gives us our actor context. Now, beneath these, we need a linear color, a float, a vector, and a vector. Now, let's start with the vector. So you can see that we've got 2 locations here, but one of them has got out next to it, and one of them has in next to it. Now we don't need to set the out because it's an output pin. But what we can do is we can, on the input to the move to location, we can select the previous task as an input to it. So at this point, you can see that the input to the move to location is going to be the output of the find random location. Now, we still have a couple more. What we have is the linear color and the float. Now, in order to set these, I'm going to use the parameters that we have up here. Leave that for a second. So I am going to add in 2 parameters. The first one, so I'm going to change the first one so that it is a float. And I'm going to set the value to 200. And I will rename that to speed. And then below this, the next one, I'm going to change to a linear color. So search for linear, and we have linear color here. I'm going to rename that to color. And I will change this to yellow, like we had last time. And now I can use these 2 parameters as inputs. So in this case, I will use, I just need to compile. So what is this? That's a find linear color. That's parameter.
They're in wander about. If you drop down, you got wander about. Yeah.
Thank you. Okay, so it's in wander about. So it's in the state. So we're grabbing it from the state. So we've got wander and color. and speed again is in wander about. So, and if I push compile now, we should see that we have compiled and we have our first setup. So what's interesting is change color, change speed, and find random location. They'll fire in this order, but the only one that's denoting how long this task runs for is the move to location. And when this is finished, we have a default transition, which is going to take us to root. So I'll compile and save. I'm just going to test this. I would drop back to it in a second. Yes, it is working. All of the characters are wandering around, finding a random location, and they're just continuing to wander about. So hopefully you guys have that working. Okay, I think I'm gonna move on. I mean, we've got a lab after this, so if you guys are stuck, we can go back over it. Or otherwise you can check the finished versions. But I'd like to get through all this kind of in the next 10 minutes, so the recording's got it all down. Right, okay, so I'm going to jump on to the next thing. So the next thing that I want to do is I want to change this, but only if we've seen the player. So in order to do that, what I'm going to do is I'm going to use a evaluator. I'm not sure it's called. So under evaluators, I'm going to push plus, and I'm just going to grab the STE to distance to player. So this functions very much like our previous one. We've got the input of the NPC and the player output. If we find the player, it will save it and it will be accessible through the evaluator. So this is our distance checker. Now, you can have a look at the evaluator if we want, but it functions. We can look at that outside the class, but it functions almost in exactly the same way as the decorator we used, the service we used in the last one. However, it keeps the variable saved within the evaluator rather than saving it to the blackboard. So we need to reference the evaluator if we want to check for that variable. So next up, I want to add a new state, and this is going to be the draw weapon state. So I'm going to type in draw weapon. Now, in this draw weapon state, I'm going to add in a couple of tasks. I'm going a little bit faster this time, so if you can keep up, great. If not, I'll just watch. So the first thing I'm going to do is I'm going to set a change color. And the second thing I'm going to do is I'm going to use the draw weapon task. Now, let's look at the inputs. I'm going to need a linear color. And apart from that, everything else is just the actor. So I will add a parameter. Again, I'm going to select a linear color. I'm going to rename this to color. And I'm going to change it to, I'm going to use purple. So it's primarily so you can see the difference in states. And again, under the draw weapon, I will select the color. So that is all fine. So I have my new state. What I don't have, okay, I've got to have a binding on here. So the input actor needs to be the actor. So that should fix that. Okay, what I don't have is any means to move to this state at this point. So we're going to use the evaluator in order to change the flow. So I am going to select the wander about. Who's the decorating player? Use the draw weapon. Okay. So I'm going to add in. So if we are wandering about, I want to add in a transition. At the moment, we haven't looked at transitions, but we've got entry conditions that allows you to enter it, and we've got transitions which allow you to move into another one. Now, at the moment, the entry condition on this hasn't been set, so it just will always allow you to enter it. But transition. Now we are going to need. I'm going to open up the finished version so on the other screen, so make sure I can get everything down. So on the transition, on the wander about, what I need is 2 transitions. So the first one is on state completed, go to state root. That's fine. There's no problem with that. When it's completed, we want it to go back to the state root. However, we're going to add in a second transition. And this is going to be on tick, because we want to check this on constantly. And that is, and so on tick, we want to check this. And what we're going to do is we are going to transition to the draw weapon state. And we're going to put the position time, the priority to high. So, and we're going to add a condition to this. And the condition is, we're going to look for, where is object valid? And for is object valid, we're going to give it from the evaluator, we're going to give it the player. So in this case, what we are doing is we've created a new transition, and this is on tick, go to state draw weapon. And what it will do is if the object is valid, so if we've seen player on tick, it's going to transition to the draw weapon state. Okay, so let's compile. No errors. Let's give this a quick go. So you can see now, as I've got close to the player, they draw the weapon and turn and face me. Now, they don't have another state to go to, so you can see that they're flipping back into the wander about, and then they're coming immediately out to the draw weapon state again. So let's come out of that. Again, I'm not really going to be pausing at this point because we're quite near the end, and we're going to be in the lab in a minute, so we'll be able to run over stuff. But again, I want to transition because I've drawn the weapon. So I'm going to create a new state off of the root, and I'm going to call this attack player. Now, what I want to do is after we have drawn the weapon, I want to create a transition out of the draw a weapon. So, and on this, I'm just going to leave this to when it's completed. So as soon as the drawn weapon task, these are tasks is finished, I'm going to go straight to attack player. I'm going to do compile. Now, the attack player, I'm going to create 2 states under this attack player. I'm going to create one state that is called chase player, and another state which is called swing weapon. So what this allows us to do is with the chase player, I'm going to add in a couple of tasks. So as soon as I go to attack player, it's going to go into this task. Then I'm just going to loop around this area. So I'm going to chase player. If I'm close enough to them, I'm going to swing the weapon. So the chase player, I want to add a task, and that task is change color again. And I'm going to add another task. And this is called update speed based on distance. So this is the task that's going to run, and it's just going to change the speed of the character based on how far away we are. So if you're very far away, it's going to run. If we're close, it's going to slow down so that we can hit. And finally, I'm going to go for chase actor. And this is the controlling class. Now, again, I need to set the inputs. So I am setting the actor as the first one. So this is the context. And the distance from player, I'm going to get that from our evaluator. The part of the evaluator, I'm establishing the distance from color. And the actor to chase, again, from the evaluator, I'm going to select the player. And finally, I need another color. So I will change this to linear color. And rename it to color. And I'm going to set this as the color. So we are going to change color. I'm going to update the speed, and this is on tick. So it's going to constantly be updating the speed based on how far away I am from the player. And then on transition at the end, I don't want it to go back to root. I want it to go back to attack player. So when that's finished, it goes back to attack player, and it will swing the weapon or chase player again. So let me check if that is working. Right, the character. Now he turns black because I've set the color to black. I kind of like black. So, and they're chasing me. Okay, so we have chase player down. What we don't have is the swing weapon. So let's get swing weapon. And this only requires one task, and that is swing weapon. And that requires the input of the actor again. And we can get rid of this by just using the context, but I'll need to update the project to do that. So we've got swing weapon, no color change or anything else. The only thing that we need to do for this is we want to go back on completed to attack player. So we're staying within this loop. Now, what we do need, though, is at the moment, we are never going to get to this swing player, swing weapon. Now, we can get to it if we add a entry condition to the chase player. So the chase player, I am going to add an entry condition here. What this is going to be is this is going to be a float compare. And the float I want to compare is the distance to player. And I think I can just manually enter in the right, so it's 100. And it is greater than 100. So what this is saying is if the distance to player is greater than 100, then you can chase. If it's not, you cannot enter the chase player. You can see the question mark at the beginning of it. And that means that you will go down to the swing weapon. So let's try that. So now they draw the weapon. They're close enough, so they're hitting me. I grab a couple more of these guys. They chase me if they're far away. And when they get close, they wander up and they start hitting me with their clubs. Probably should turn collision off on the last. Now, it's a very basic example of how you might run with AI like this, but it sort of demonstrates it. Look, we're only 4 minutes past. That's not too bad. Is there any sort of time sensitive questions or anything in chat we should do now, or should we just finish up and jump into the lab? I hope you guys. Oh, I'll see you in lab. I'll catch you then.